Intro. 20-second hook, all right. Let's talk about something that's genuinely shifting the tectonic plates of military strategy in South Asia. For years, the idea of a missile that could literally slip under the radar, navigate complex terrain with pinpoint accuracy, and then deliver a devastating blow hundreds of kilometers away, well, that sounded like something straight out of a Hollywood blockbuster, didn't it? Like a spy thriller where the protagonist has some impossibly advanced gadget. Yesterday, that was pure science fiction. Today, Pakistan calls it the FATAH-4, and trust me, if you're one of the crews manning India's formidable S-400 air defense systems, you're probably not getting much sleep these days. And by the time we wrap up this deep dive, you'll understand exactly why this missile is causing such a stir. This isn't just another weapon. It's a paradigm shift, a strategic equalizer that changes the entire calculus of regional power. Why everyone is talking. For what feels like an eternity, a good 2 decades at least, the military dance between India and Pakistan in South Asia has followed a predictable, if dangerous, rhythm. It's been a classic cat-and-mouse game, where one side acquires a more robust shield, and the other responds by forging an even sharper spear. This dynamic has driven an intense, often covert arms race that keeps defense analysts and policymakers perpetually on edge. India's acquisition of the S-400 Triumph air defense system from Russia was supposed to be the ultimate game-changer, the definitive move that would flip the chessboard entirely. This wasn't just any air defense system. It was lauded as one of the most advanced on the planet. The S-400 boasts an incredible capability. It can track up to 300 targets simultaneously and reportedly engage anything out to a staggering 400 kilometers. Imagine that kind of protective dome, a virtually impenetrable bubble designed to swat down incoming threats, whether they're aircraft, ballistic missiles, or even other cruise missiles, with a high degree of confidence. For a while, it seemed like India had indeed bought itself a significant strategic advantage, a shield so powerful it might render many of Pakistan's offensive capabilities obsolete. But Islamabad, as always, had a different plan, a rather ingenious countermove. Instead of trying to punch through that seemingly impenetrable S-400 sky shield, they decided to simply bypass it. Their answer? Don't fly high, where the S-400's powerful radars can easily spot you. Instead, skip the sky altogether and fly in the weeds, hugging the terrain so closely that you become almost invisible. This is where the FATAH-4 steps in, a missile built with an almost defiant design philosophy. It's engineered to hug the deck, flying at an incredibly low altitude, sometimes as low as 50 meters above the ground. This isn't just a minor technical detail. It's a crucial design choice that exploits a fundamental vulnerability of even the most advanced air defense radars. By staying so low, the FATAH-4 ducks below the radar horizon, effectively disappearing into the ground clutter, that messy, noisy return that radars get from trees, buildings, hills, and even flocks of birds. It pops up only when it's far too late for an effective interception. This single, seemingly straightforward design choice completely turns the traditional cost-benefit analysis of air defense on its head. Think about it. You have a multi-million-dollar S-400 battery, bristling with advanced radars and expensive interceptor missiles, representing a colossal investment in national security. Suddenly, that incredibly sophisticated, multi-layered defense system is forced to contend with a missile like the FATAH-4. Analyst chatter suggests the FATAH-4 costs somewhere between $800,000 and $1.2 million per round. That's a significant sum, but it's a fraction of the cost of the S-400 system itself, and far less than the aircraft and pilot it protects. This isn't just about monetary value. It's about the psychological and operational stress it places on the defender. Imagine a $50 million S-400 battery, designed to protect critical assets, suddenly having to deal with a swarm of these relatively inexpensive, low-flying threats. It's like trying to stop a freight train with a fly swatter that costs a fortune, mind you. The FATAH-4 looks like a bird on radar, flies like a bird, but when it hits like a literal freight train. This missile isn't merely a technological achievement for Pakistan. It's a strategic headache for anyone trying to defend against it. What the numbers actually say. Let's dive into the cold hard facts, the specifications that truly define the FATAH-4 and underscore its capabilities. These aren't just abstract figures. They translate directly into strategic advantage and operational impact. First, let's talk about range. The FATAH-4 boasts a reported operational range of 750 kilometers. Now that's already a substantial reach, capable of striking deep into adversary territory. But here's where it gets interesting. Sources suggest this can be stretched to 800 kilometers, especially if the missile's fuel algorithm is instructed to ignore its safety buffers. What does that mean in practical terms? It implies a design with inherent flexibility, allowing commanders to push the envelope when the mission demands it, sacrificing a bit of conservatism for extended reach. This stretchable range offers critical tactical depth, putting more high-value targets within striking distance. Next up, speed, Mach 0.7. For some, that might sound slow in an age obsessed with hypersonics. But don't let that number fool you. It's a deliberate and highly strategic choice. Mach 0.7 is firmly subsonic, and there's a very good reason for that. When an object travels at hypersonic speeds, Mach 5 and above, the intense friction with the air causes it to heat up dramatically, creating a fiery plasma trail that ionizes the air around it. This ionized air, and the sheer heat signature, acts like a giant beacon, loudly advertising the missile's presence to infrared sensors and even some radar systems. A subsonic cruise missile, on the other hand, whispers through the air. It doesn't ionize the air, it doesn't create a massive bow shock wave, and its heat plume is significantly smaller and cooler, often remaining below the horizon for space-based satellites. This makes it incredibly difficult to detect, especially when combined with its low-altitude flight profile. It's stealth by subtlety, preferring to arrive unnoticed rather than with a blazing, impossible-to-miss fanfare. The recycler. Warhead. A hefty 330 kilograms of conventional high explosive. This isn't some token payload. It's a serious punch. What can 330 kilo of HE do? It's more than enough to crater a runway, rendering an airfield temporarily unusable and disrupting air operations for hours, if not days. It can gut a command bunker, taking out critical leadership and communication nodes, or with specialized submunitions it could disperse across a wide area, targeting aircraft on the ground or disrupting logistics. This warhead is versatile enough to inflict significant damage on critical infrastructure, making it a potent tool for conventional precision strikes. Perhaps the most impressive number is the Ankipairas under 5 meters. For those unfamiliar, CEP stands for Circular Error Probable, and it's a measure of accuracy. A CP of under 5 meters means that, on average, half of the missiles fired will land within a radius the length of a typical sedan. Think about that for a moment. This isn't just hitting a city. This is hitting a specific building, a specific bridge abutment, or even a specific hardened aircraft shelter. This level of precision transforms the FATAH-4 from a blunt instrument into a finely tuned scalpel, allowing for highly discriminate targeting and minimizing collateral damage. A crucial factor in modern warfare, especially when trying to avoid escalation. It's an altitude band. This missile is incredibly flexible, capable of operating as a sea skimmer at a mere 50 meters above the surface, all the way up to 150 meters. The key here is that this altitude is user-selectable by waypoint. This means mission planners can program the missile to fly low over flat terrain, dip even lower over water to avoid naval radar, and then rise slightly to clear obstacles like hills or buildings, all while maintaining its stealthy profile. This adaptability makes it incredibly difficult for static air defense systems to predict its approach path or set effective interception parameters. And finally, there was mission set. What kind of targets is the FATAH-4 designed to engage? Its capabilities make it ideal for a range of critical missions, disabling airfields by cratering runways and destroying control towers, smashing radar nodes, effectively blinding enemy air defenses, cutting vital bridges to disrupt logistics and troop movements, or taking out power transformers, plunging critical installations into darkness. These are jobs that were historically reserved for manned airstrikes, missions that put highly trained pilots and billion-dollar jets at immense risk. The FATAH-4 offers a way to achieve these strategic objectives without risking precious human lives or incredibly expensive airframes, fundamentally altering the risk-reward equation for offensive operations. The tech stack that makes it unstoppable. So, what kind of technological wizardry goes into making a missile that can pull off these kinds of feats? It's not just one magic bullet, but a sophisticated blend of cutting-edge systems working in harmony, creating a weapon that is far more than the sum of its parts. Let's peel back the layers and look at the tech stack that gives the FATAH-4 its formidable reputation. Forced out a multi-mode navigation. This isn't your granddad's cruise missile relying on a single easily jammed GPS signal. The FATAH-4 employs a robust, multi-layered navigation system that ensures it stays on course even in the most hostile electronic warfare environments. At its core are high-precision inertial ring laser gyros. Think of these as incredibly accurate internal compasses that constantly track the missile's position, speed, and orientation without any external input. But these gyros aren't left to drift. They're continuously updated and refined by data from not one, but 3 global navigation satellite systems, GNSS, Russia's GLONASS, America's GPS, and China's Beidou. This isn't just about having options. It's about redundancy and resilience. All this incoming data feeds into a sophisticated Kalman filter, an algorithm that intelligently combines noisy measurements to estimate the missile's true state with remarkable accuracy. What does this mean for an adversary? It means if you manage to jam one satellite constellation, the other 2 are still feeding precise location data to the missile. To truly throw the FATAH-4 off course, an enemy would need to simultaneously drown out 3 separate GNSS frequencies at once, a task of immense complexity and power, requiring a level of electronic warfare capability few nations possess. This multi-mode approach makes the FATAH-4 incredibly robust against even advanced jamming attempts. Terminal eyes. Getting close is one thing. Hitting the bullseye is another. That's where the FATAH-4's terminal eyes come into play, providing the precision needed for its sub-5 meter CEP. This missile is equipped with advanced electro-optical, EO, and infrared, IR, seekers. As the missile approaches its target area, typically around 30 kilometers out, these seekers activate, essentially taking high-resolution pictures of the ground below. These live images are then compared in real time with a stored image or a digital map of the target area that was preloaded into the missile's memory during mission planning. This is often referred to as digital scene matching area correlation, DSMACI, or image scene matching. It's a bit like facial recognition but for terrain. If the target has moved slightly, or if there are minor discrepancies due to changes in lighting, weather, or even recent damage to the target, a sophisticated algorithm within the missile reassigns the aim point to the nearest matching object or the most critical feature of the target. This AI-enabled capability ensures that even if a static target has been obscured or partially destroyed, the missile can still identify and strike the most relevant part of the objective. This makes it incredibly effective against hardened structures, ensuring that the warhead impacts exactly where it will do the most damage. Signature control. How do you make a missile hard to see on radar? You control its signature. The FATAH-4 incorporates several stealth design features aimed at drastically reducing its radar cross-section, RCS. It utilizes a composite skin, meaning its outer shell isn't just metal but advanced radar-absorbent materials that dissipate or deflect radar waves. Its design likely features sawtooth edges, which are angled surfaces that break up and scatter radar reflections, preventing them from returning directly to the enemy radar. Think of it like a faceted gemstone, where light bounces off in many directions rather than reflecting a single strong beam. Furthermore, the engine inlet, typically a major source of radar reflection, is buried deep within the missile body, shielding it from direct radar illumination. All these design elements combine to drop the missile's radar cross-section below 0.05 square meters. To put that into perspective, that's smaller than a cricket helmet. This tiny RCS, especially when combined with its low-altitude flight, makes it incredibly difficult for conventional radars to detect, track, and get a weapons-grade lock on the missile. Waypoint flex. Imagine trying to hit a target but having to fly in a straight line, directly into the teeth of the enemy's defenses. That's a recipe for disaster. The FATAH-4 bypasses this problem with an astonishing degree of tactical flexibility. It can be programmed with up to 255 programmable waypoints. This isn't just a few turns. It's an intricate, customizable flight path. This allows mission planners to design routes that artfully skirt around known surface-to-air missile, SAM bubbles, avoid heavily defended areas, and leverage natural terrain features for concealment. Instead of flying the shortest, most obvious line to the target, The FATAH-4 can weave, turn, and maneuver, making its trajectory highly unpredictable. This significantly complicates the defender's task of setting up interception zones or predicting the missile's approach, effectively forcing them to defend a much larger area with fewer resources. Pop up and dive. Even if a missile manages to evade detection and reach the target area, actually destroying a hardened target like a bunker or a protected aircraft shelter requires a specific impact profile. The FATAH-4 has a clever trick up its sleeve for this: the pop-up and dive maneuver. About 5 kilometers from its final target, the missile, which has been hugging the deck, suddenly climbs sharply to an altitude of around 180 meters. This momentary pop-up gives it the necessary height and angle. Then it immediately pitches down and dives at a steep 45-degree angle, followed by a sharp pull-up just before impact. The result? The warhead slams into the target at a near vertical 90-degree angle. Why is this so crucial? Because hitting a horizontal surface from directly above is the most effective way to penetrate revetments, hardened concrete shelters, and the reinforced roofs of command bunkers. It maximizes the kinetic energy transfer and explosive effect, ensuring the warhead doesn't just glance off but penetrates deep before detonating. When you put all these technologies together, the resilient navigation, the intelligent terminal guidance, the stealthy design, the flexible routing, and the specialized terminal maneuver, you realize the FATAH-4 isn't just hard to see. It's incredibly hard to predict, and even if you do spot it, it's designed to be extremely challenging to intercept. It's a truly integrated system built for survivability and precision. Section 4. How India's S-400 sees the threat now. Let's turn the tables and consider this from the perspective of India's formidable S-400 air defense system. On paper, the S-400 is an absolute beast, a cutting-edge piece of Russian engineering designed to dominate the skies. Its 92N6E multifunctional fire control radar, a core component, theoretically lists a detection threshold of around 0.01 square meters. That's an incredibly small radar cross-section, suggesting it should be able to spot even advanced stealth aircraft. But here's the critical caveat, the elephant in the room that often gets overlooked. That impressive detection range is typically against a target flying at medium to high altitude, against a clean, uncluttered sky. In that pristine environment, the radar has a relatively easy job. Down in the real world, however, especially at the low altitudes the FATAH-4 operates, the equation flips entirely. This is where ground clutter becomes the S-400's Achilles heel. Imagine trying to pick out a tiny bird flying just above the treetops during a thunderstorm. That's essentially the challenge. The radar signal bounces off everything: trees, buildings, moving vehicles, even flocks of actual cranes. The S-400's signal processing, no matter how advanced, has to work overtime to differentiate a tiny 0.05 square meter object, like the FATAH-4, from all that environmental noise. It's a monumental task, and the effectiveness of even the most sophisticated radar systems diminishes dramatically in such conditions. Experts and even some S-400 operators acknowledge that the system struggles with low-altitude threats and needs to be integrated into a broader, more robust air defense strategy to be truly effective. This highlights a significant vulnerability that the FATAH-4 is specifically designed to exploit. Even if the S-400 does manage to get a paint on the FATAH-4, that fleeting moment of detection, the clock starts ticking, and it ticks incredibly fast. The reaction time for an S-400 battery from first detection to a missile being launched, missile away, is roughly 90 seconds. That sounds quick, right? But consider this. At Mach 0.7, the FATAH-4 covers approximately 20 kilometers in those 90 seconds. So if the FATAH-4 is already inside, say 200 kilometers when it's first detected, that leaves a dangerously small window for the S-400 to react. The intercept window collapses to one desperate ripple fire, a frantic attempt to launch multiple interceptors in quick succession, hoping one of them gets lucky. And here's another brutal truth. Even an impressive 90% kill probability per surface-to-air missile isn't enough when you're facing a saturation attack. If 3 or 4 FATAH-4 cruise missiles are arriving in the same minute, even with a 90% kill rate, the defender is statistically likely to let one or more through. This is the arithmetic Pakistan banks on, a strategic calculation that prioritizes saturation over individual missile evasion. The idea isn't that every FATAH-4 will get through. It's that enough of them will. The sheer volume of incoming, low-flying, stealthy targets can overwhelm even the most advanced air defense system, forcing it to make impossible choices and ultimately leading to successful strikes. It's a numbers game, and Pakistan intends to play it with overwhelming odds in its favor. Why not go hypersonic? In today's defense discussions, hypersonic is the buzzword, the ultimate aspiration for many militaries. Speed is undeniably sexy. It conjures images of unstoppable projectiles streaking through the atmosphere. But here's the thing, speed shouts, a hypersonic glide vehicle, traveling at Mach 5 or faster, generates immense heat due to aerodynamic friction. This intense heat signature makes it light up infrared sensors like a match struck in a pitch-black room. It's incredibly fast, yes, but it's also incredibly visible, practically announcing its arrival to every sensor in the vicinity. A subsonic cruise missile like the FATAH-4, on the other hand, whispers. It glides through the air without the dramatic heat signature of a hypersonic weapon. It produces no bow shock, that distinct pressure wave that faster-than-sound objects generate, which can be detected by specialized sensors. Crucially, its relatively cool heat plume often remains below the horizon of space-based infrared satellites, further enhancing its stealth. It's a philosophy of stealth by subtlety, preferring to arrive unannounced rather than with a blazing, impossible-to-miss fanfare. Pakistan already possesses the nuclear-tipped Shaheen series of ballistic missiles for strategic deterrence, weapons designed for sheer, unadulterated velocity and the ultimate existential threat. The FATAH-4 fills a completely different yet equally critical conventional gap. This is where quantity matters far more than raw velocity. For conventional warfare, Islamabad wants a weapon it can fire not just one or two of, but potentially 50 in a single night. Why? Because launching a large number of conventional cruise missiles allows for saturation attacks, overwhelming enemy defenses without immediately escalating to the nuclear threshold. The key here is escalation control. Firing a nuclear-capable ballistic missile is a monumental decision, fraught with the risk of immediate and devastating retaliation. It's a red line that no nation wants to cross. The FATAH-4 offers a potent conventional option, a way to inflict significant damage and achieve strategic objectives without appearing to inch toward that terrifying nuclear threshold. It provides leaders with a crucial option between doing nothing and pressing the red button, giving them a flexible instrument for conventional deterrence and punitive strikes. This strategic choice reflects a mature understanding of modern conflict dynamics, where the ability to fight effectively below the nuclear level is paramount. The Army Rocket Force command angle. Until very recently, Pakistan's impressive array of cruise missiles like the Babur primarily resided within the purview of the Air Force or the Strategic Forces Command, often associated with nuclear deterrence. This organizational structure reflected a certain historical context and doctrinal approach. However, the FATAH-4 signals a significant shift, not just in missile technology, but in military doctrine and command structure. It's the first major cruise missile to be rolled out under the brand new Army Rocket Force Command, ARFC. The formation of the ARFC, announced in August 2025 by Prime Minister Shehbaz Sharif, is a monumental development for Pakistan's military. It essentially creates a separate, dedicated conventional missile army, explicitly modeled on the Chinese PLA rocket force. What does that mean in practice? The Chinese PLA-RF is an independent branch of the military, separate from the Army, Navy, and Air Force, solely responsible for operating and managing China's land-based missile arsenal, both conventional and nuclear. While Pakistan's ARFC will initially focus on conventional capabilities, this move mirrors the PLA-RF's emphasis on unified command and specialized expertise. This bigger picture move is incredibly strategic, consolidating short-range rockets, cruise missiles like the FATAH-4, and potentially future anti-ship weapons under one unified command offers a multitude of advantages. Firstly, it significantly shortens sensor-to-shooter loops. In military parlance, this means the time it takes from detecting a target to launching a weapon at it is drastically reduced. A dedicated command streamlines intelligence gathering, target identification, and authorization processes, making responses faster and more decisive. Secondly, it simplifies inventory management and logistics, ensuring that the right missile is available at the right time and place. No more bureaucratic silos or inter-service squabbles over assets. But beyond the operational efficiencies, the ARFC sends a powerful signal to Delhi. It demonstrates Islamabad's serious commitment to matching India's growing conventional missile capabilities, including its own burgeoning rocket corps, without needing to tap into strategic nuclear assets. It shows that Pakistan is building a robust conventional precision strike capability that is agile, responsive, and independent of its nuclear deterrent. This separation of conventional and nuclear missile forces allows for greater flexibility in responding to conventional provocations, providing a vital layer of deterrence below the nuclear threshold. It's about having more options, more levers to pull before contemplating the unthinkable. Cost per shot math. Let's talk brass tacks, or rather greenbacks. In the world of modern weaponry, cost isn't just a budget line item, it's a critical strategic factor. Cheaper weapons, especially effective ones, can fundamentally alter the balance of power by allowing for greater numbers and thus, greater saturation capabilities. Consider some open-source estimates for comparable cruise missiles. A U.S. Tomahawk, a widely recognized and highly capable land attack cruise missile, is generally priced around $1.5 million to $1.9 million per round. India's indigenous Nirbhay cruise missile is estimated to cost about $1.4 million to $1.5 million per round. Now, when we look at the FATAH-4, analyst chatter and various reports put its unit cost significantly lower, somewhere between $800,000 and $1 million per round. Why is this price difference so crucial? Because cheaper means you can build and fire more of them. This isn't just about saving money. It's about achieving saturation. If you can acquire 2 FATAH-4s for the price of 1 Tomahawk or Nirbhay, you've effectively doubled your offensive capability for the same budgetary outlay. Let's put this into a more tangible comparison. 40 FATAH-4 missiles at roughly $1 million each would total $40 million. That might sound like a lot, but consider the cost of modern fighter aircraft or their upgrades. For instance, a single upgrade for a Mirage 2000 fighter jet can easily run into the tens of millions of dollars. The cost of a new advanced fighter jet can be well over $100 million, not including maintenance, pilot training, and operational costs. This stark cost differential allows Pakistan to trade dollars for deterrence in a highly efficient manner. Instead of investing colossal sums into airframes that risk pilots and are vulnerable to advanced air defenses, they can acquire a significant number of precision strike missiles that can achieve similar, if not superior, tactical effects. In a budget fight where every defense dollar counts, this ability to deliver powerful conventional deterrence at a relatively lower cost per shot is a massive advantage. It means Pakistan can project power and hold critical enemy assets at risk without bankrupting its treasury. Or more importantly, without risking its highly trained pilots in contested airspace. It's a calculated, pragmatic approach to modern warfare. Comparison with Pakistan's own Babur. To truly appreciate the FATAH-4, it's helpful to compare it with its predecessor and stablemate within Pakistan's own arsenal, the Babur series of cruise missiles. The Babur, particularly the Babur 1A, has been a cornerstone of Pakistan's conventional, and some believe, nuclear cruise missile capability for years. Let's look at the numbers for the Babur 1A. It had a range of approximately 700 kilometers, a circular error probable, CEP, of around 10 meters, and carried a substantial 400-kilogram warhead. The Babur was and remains a potent weapon. It was designed to deliver a heavy punch and reach deep into enemy territory. Now let's stack the FATAH-4 against that. The FATAH-4 stretches the range to 750 kilometers, with the potential for 800 kilometers. Crucially, it halves the CEP to under 5 meters. While it trades a bit of warhead weight, carrying 330 kilos compared to Babur's 400 kilo, it does so for significantly better seekers, the advanced EOIR and multi-mode navigation systems we discussed earlier. Think of it this way. The Babur was like a powerful sledgehammer. It could hit hard and destroy big targets. The FATAH-4, while still hitting hard, is more like a finely tuned scalpel. It sacrifices a small amount of raw destructive power for vastly improved precision and the ability to hit specific, critical points with surgical accuracy. This shift from a blunt instrument to a precision tool is a hallmark of modern military doctrine, where minimizing collateral damage and maximizing target effect are paramount. But the differences extend beyond raw specifications to operational flexibility. The Babur, in its earlier iterations, often required dedicated transport like C-130 cargo planes or ATR aircraft to move its launchers to forward operating sites. This reliance on larger, less stealthy transport made its deployment somewhat more complex and potentially vulnerable. The FATAH-4, however, takes a leap in mobility and concealment. Its launcher is designed to be a standard 6x6 wheeled truck, which possesses significantly greater cross-country mobility and can be deployed much more rapidly and discreetly. Even more impressively, the entire launcher system can hide inside a standard 40-foot shipping container. This means it can be transported covertly on civilian-looking trucks, blend into regular commercial traffic, and deploy from unexpected locations, making it incredibly difficult for enemy intelligence to track or target its launch platforms. This operational stealth and flexibility are massive advantages in a highly contested environment. Real-world scenario, not wargaming. Let's move beyond the dry technical specs and imagine a plausible, albeit hypothetical, real-world scenario. This isn't just wargaming. It's the kind of situation that military planners on both sides of the line of control constantly run through. Imagine Day X. Tensions between India and Pakistan have spiked dramatically after a particularly nasty incident on the line of control. The situation is precarious, teetering on the brink of wider conflict. Islamabad, seeking to deliver a strong conventional message without crossing the nuclear threshold, decides to disable India's forward airfield at Awantipur, a critical operational base located about 200 kilometers from the border. Under the cover of darkness, 2 FATAH-4 batteries deploy. They're not using large, obvious military convoys, but rather discreet 6x6-wheeled trucks, perhaps disguised as civilian transport, moving under the cloak of night near Gujranwala, approximately 260 kilometers from the target. Their mobility allows them to choose optimal launch positions, making detection by satellite or aerial reconnaissance incredibly difficult. At the designated time, they fire 6 FATAH-4 missiles, staggered just 90 seconds apart to maximize saturation and overwhelm defenses. Each missile is assigned a specific role, leveraging the FATAH-4's versatile warhead options. Missiles 1 and 2 carry runway cratering submunitions, designed to create massive holes and render the main runway unusable. Missiles 3 and 4 are equipped with anti-radar seekers, tasked with homing in on and destroying any active S-400 or other air defense radars in the area, effectively blinding the defender. Missiles 5 and 6 carry blast fragmentation warheads, aimed at hardened aircraft shelters, designed to penetrate and destroy valuable fighter jets or other high-value assets parked within. The flight paths are meticulously planned. Waypoints bend south of the S-400 arc, based on the last known positions of India's air defense assets, carefully evading predicted interception zones. The missiles hug the terrain, flying low and fast. The total flight time to Awantipur is a mere 22 minutes. Meanwhile, Indian intelligence is struggling. Earlier satellite passes, hampered by weather or clever camouflage, missed the mobile FATAH-4 transporter erector launchers, TELs, under their camo nets. Delhi's first real alert is a radar blip, a faint signal indicating an incoming threat only 50 kilometers out. The S-400 crew scramble, but with such short warning, the intercept window is agonizingly tight. In the ensuing chaos, 4 of the 6 incoming missiles are knocked down by a desperate flurry of S-400 interceptors. It's a testament to the S-400's power, but it's not enough. 2 FATAH-4s get through. One missile, carrying its runway cratering payload, slams into the main runway, blowing a massive crater and effectively closing air operations for the next 36 hours. The other blast fragmentation missile impacts a hardened aircraft shelter, severely damaging, if not completely destroying, a valuable MiG-29UpG fighter jet parked inside. The strategic outcome? A clear, undeniable conventional message has been delivered. Pakistan has demonstrated its ability to strike critical Indian military infrastructure with precision, inflict significant damage, and disrupt operations, all without crossing the nuclear threshold. It's a calculated act of conventional deterrence, showing capability and resolve, but carefully avoiding the catastrophic implications of nuclear escalation. This scenario underscores the FATAH-4's role as a potent tool for limited, punitive strikes, changing the game in regional conflict management. International reception. When a new highly capable weapon like the FATAH-4 emerges on the global stage, especially from a nuclear-armed nation in a volatile region. The international community takes notice. The reactions, often couched in diplomatic language, reveal underlying geopolitical currents and concerns. Washington's message, delivered through official channels, was typically cautious. We urge restraint by both nuclear-armed states. This is standard diplomatic boilerplate, a predictable call for de-escalation. But the translation, for those who understand the nuances of international relations, is quite telling. We're not sanctioning anyone yet. It implies a recognition of the new capability, an acknowledgement of the heightened tensions, but also a desire to avoid further destabilization by immediately taking sides or imposing punitive measures. The U.S. wants stability, and a new conventional weapon that complicates regional deterrence without immediately leading to nuclear brinkmanship is something they'll observe closely. Beijing's readout, however, struck a different chord. China, a close ally of Pakistan and a significant player in regional security, called the FATAH-4 a stabilizing conventional deterrent. This isn't just polite diplomatic phrasing. It's diplomatic code for, we will not block future sales or technology transfers, and we view this as a legitimate enhancement of Pakistan's defensive capabilities. From China's perspective, a stronger, conventionally capable Pakistan acts as a counterweight in the region, potentially balancing India's growing military might. A stabilizing deterrent means it makes the region less likely to escalate to nuclear conflict by providing a viable conventional option. Moscow, on the other hand, the primary supplier of India's S-400 air defense system, stayed conspicuously silent, diplomatically mute. This silence in itself speaks volumes. While official government channels remained quiet, industry blogs and defense analysts associated with Russian military manufacturing began to grumble. The sentiment was clear. Export-grade radars like those in the S-400 were being embarrassed. The FATAH-4's ability to potentially bypass or overwhelm their flagship air defense system is not good for business or Russia's reputation as a top-tier arms exporter. It raises questions about the efficacy of their systems in real-world scenarios against new threats, potentially impacting future sales to other nations. The FATAH-4, therefore, isn't just a regional concern. It's a quiet challenge to the global arms market and the perceived invincibility of certain high-end defense systems. What happens next? The introduction of the FATAH-4 into Pakistan's arsenal isn't an isolated event. It's a catalyst that will inevitably trigger a new round of responses and counter-responses in the ongoing South Asian arms dynamic. This isn't a static chessboard. It's a constantly evolving, high-stakes game. India, now facing a potent, low-observable precision strike threat, will almost certainly fast-track its own defensive upgrades. Expect to see a significant push for more MR-SAM, medium-range surface-to-air missile airfield defense batteries. The MR-SAM, a joint Indian-Israeli development, is designed to provide robust air defense against a variety of aerial threats, including cruise missiles, within a range of about 7,100 kilometers. Deploying more of these systems specifically around critical airfields would create denser, lower-tier defensive layers to complement the S-400. Beyond that, India will likely procure more Israeli Barak 8 interceptors. The Barak 8, also a joint Indian-Israeli project, is a highly capable surface-to-air missile system designed to intercept aircraft, helicopters, anti-ship missiles, and UAVs. With an operational range that can extend to 100-150 kilometers for its extended range variants, these missiles, when integrated into a layered defense network, offer a crucial capability against threats like the FATAH-4. India's strategy will be to create multiple, overlapping defensive envelopes, making it harder for any single missile to penetrate. But the response won't just be about traditional SAMs. Expect to see innovative solutions emerging. Within the next 18 months, don't be surprised to witness rigorous testing of drone-mounted AWACS, airborne warning and control system platforms. Instead of billion-dollar manned AWACS aircraft, which are vulnerable and expensive to operate, India might invest in cheaper, turbofan-powered UAVs. These drones could be designed to park at high altitudes, perhaps 12 kilometers or more, and look down for low-flying cruise missiles. This look-down capability, combined with advanced radar, could help overcome the ground clutter issues that plague ground-based radars, offering an earlier detection capability against missiles like the FATAH-4. It's a smart, cost-effective way to extend their radar horizon. Pakistan, for its part, is certainly not resting on its laurels. The arms dynamic dictates continuous innovation. There's already chatter, whispers in defense circles, about the FATAH-5. This next-generation variant is rumored to boast an extended range of 200 kilometers and potentially feature a dual payload bay, allowing it to carry different types of warheads or even multiple smaller munitions for greater saturation or diverse targeting. This kind of development would further enhance Pakistan's deep strike capabilities and missile versatility. This whole situation perfectly illustrates Arms Dynamic 101. Every defense invites a new offense. The S-400 compelled Pakistan to develop the FATAH-4. The FATAH-4 will now compel India to develop new countermeasures and detection methods. It's a never-ending cycle of innovation and adaptation. A technological arms race driven by perceived threats and the relentless pursuit of strategic advantage. CTA. One, if this breakdown has genuinely altered your perspective on the complex, high-stakes world of South Asian security, do me a favor. Hit that subscribe button. It's how we keep this kind of in-depth analysis coming, and frankly, it keeps the algorithm happy, which means more people get to see this vital information. Now tell me in the comments, in this evolving arms race, do you think sheer quantity and saturation will ultimately triumph over cutting-edge quality and layered interception? Or will India's layered defense adapt fast enough to neutralize this new threat? Let's get that discussion going. Section 12. 5 Myths to Bury. The world of military technology, especially around missiles, is often rife with misconceptions and outdated notions. When a new system like the FATAH-4 emerges, it's crucial to separate fact from fiction. Let's tackle and bury 5 common myths that often cloud the discussion around cruise missiles and modern warfare. Cruise missiles are easy to shoot down. This is a persistent myth, often perpetuated by simplistic Hollywood portrayals or overconfident defense claims. The reality? Ask Saudi Arabia. In September 2019, major oil processing facilities at Abu Qaiq and Khurais, vital to global energy supplies, were struck by a coordinated drone and cruise missile attack. Despite Saudi Arabia possessing advanced Western-supplied air defense systems, including Patriot missile batteries, many of the low-flying drones and cruise missiles, no more sophisticated than the FATAH-4, managed to penetrate and inflict significant damage. The Houthis, who claimed responsibility for the attack, demonstrated that even relatively unsophisticated low and slow threats can overwhelm advanced defenses through saturation and exploiting low-altitude vulnerabilities. So no, they're not easy to shoot down, especially when employed intelligently. Subsonic is obsolete. This is another common misconception, particularly in an era fixated on hypersonic speed. But tell that to the U.S. Navy, which is still actively buying and upgrading its iconic Tomahawk cruise missiles through 2028 and beyond. The Tomahawk, a subsonic weapon, has been a workhorse of American power projection for decades, consistently demonstrating its effectiveness in various conflicts. Its subsonic speed allows for stealthy low-altitude flight, complex mission planning with numerous waypoints, and a significant payload capacity. The continued investment by a leading military power like the U.S. in a subsonic platform proves that slow can still be incredibly lethal and strategically relevant, especially when coupled with stealth and precision. Cheap equals crude. There's a natural tendency to equate lower cost with lower quality or less sophistication. However, with the FATAH-4, the simplicity is actually a feature, not a bug. While it might be less expensive than its supersonic or hypersonic counterparts, this affordability doesn't mean it's crude. Instead, it often translates to fewer moving parts, which means faster, more streamlined production processes. This allows for the rapid manufacture of larger numbers of missiles, leading to bigger stockpiles. In a conflict scenario, having hundreds of effective, precise, and affordable missiles can be far more strategically impactful than having a handful of ultra-expensive, high-performance weapons. The ability to produce in batches ensures that a nation can generate the necessary volume for saturation attacks, which, as we've discussed, is a key strategy against advanced air defenses. Pakistan cannot build seekers indigenously. This myth often stems from a historical perception of Pakistan's defense industry being largely reliant on foreign technology. However, the FATAH-4 actively debunks this. The advanced electro-optical, EO, and infrared IR terminal seekers integrated into the FATAH-4 share a clear technological lineage, or DNA, with those developed for the Ra'ad-2 air-launched cruise missile, ALCM. The Ra'ad-2 has been flight-tested since at least 2020, demonstrating Pakistan's growing indigenous capability in developing sophisticated guidance systems. This isn't about buying off the shelf. It's about developing and integrating advanced AI-enabled seekers domestically, showcasing a significant leap in self-reliance and technological prowess. Nuclear escalation is automatic. In a region like South Asia, with two nuclear-armed adversaries, there's a pervasive fear that any conventional conflict will inevitably spiral into nuclear war. While the risk is always present, conventional cruise missiles like the FATAH-4 actually work to prevent automatic escalation. They provide leaders with a crucial option, a middle ground between doing absolutely nothing in response to a provocation and immediately pressing the terrifying red button. This expanded conventional toolkit allows for calibrated proportionate responses, enabling a nation to inflict punitive damage or achieve specific military objectives, without crossing the ultimate nuclear threshold. The whole point of developing such conventional precision strike capabilities is to create a space for conflict that is below the existential level, offering flexibility and reducing the pressure for immediate, catastrophic escalation. Section 13, Environment and Accuracy Debatelet. Let's address a couple of often overlooked aspects of modern missile technology: its environmental footprint and the nuanced implications of extreme accuracy. While these might seem secondary to kinetic effects, they are increasingly important considerations for military planners and policymakers. First, the carbon footprint of a single launch. A single FATAH-4 missile launch, like any rocket or missile launch, involves the combustion of propellants, which releases greenhouse gases and other pollutants into the atmosphere. While precise figures for the FATAH-4 are proprietary, we can estimate a typical missile launch can release a notable amount of CO2. For illustrative purposes, let's say it's about 2.3 tons of CO2. To put that into perspective, that's roughly equivalent to a diesel truck driving the entire distance from Islamabad to Karachi 3 times over. It's not insignificant. However, when you compare this to the environmental impact of a traditional, multi-aircraft strike package designed to achieve similar objectives, the missile often emerges as the greener option. Imagine a strike involving 20 fighter jets, each burning tons of jet fuel, potentially requiring multiple refueling operations, and generating a massive carbon footprint over its entire mission profile. From a purely emissions standpoint, launching a few precision missiles can be far less impactful than deploying a large air armada. It's a grim calculus, but military planners are increasingly factoring environmental considerations into their operational choices, especially in an age of climate awareness. Second, the accuracy under 5 meters isn't just about hitting the target. It has profound implications for the battlefield and beyond. This pinpoint precision means fewer weapons are needed to achieve a desired effect. If you can hit a specific point on a bridge abutment or a precise section of a runway with one missile, you don't need to fire multiple, less accurate munitions in the hope of achieving the same result. This efficiency directly translates to less unexploded ordnance, UXO, littering the battlefield. Less UXO means fewer long-term hazards for civilians, less risk to post-conflict reconstruction efforts, and a cleaner environment in the aftermath of hostilities. While the primary goal of a weapon is destruction, the ability to achieve that destruction with surgical precision, thereby minimizing unintended consequences and long-term environmental and human costs, is an increasingly valued attribute. It's a harsh reality, but military planners do count these things, the human, environmental, and logistical costs, as part of their overall strategic assessment. Section 14, Lessons for Other Medium Powers. The FATAH-4 isn't just a story about Pakistan. It offers profound lessons for other medium-sized powers around the globe, nations like Turkey, Iran, or South Korea, that seek to bolster their defense capabilities without breaking the bank or relying solely on expensive foreign imports. The takeaway, loud and clear, is the power of a modular, cost-effective approach to missile development. Here's the template Pakistan has demonstrated works. Build one versatile airframe. Instead of developing entirely new missile designs for every mission, focus on a core airframe that can be adapted for various roles. This streamlines research and development, manufacturing, and logistics. Offer 3 warhead options. Design the airframe to accommodate different types of warheads, a standard high explosive, specialized submunitions, e.g. runway cratering anti-armor, or perhaps even an electromagnetic pulse EMP weapon for non-kinetic effects. This versatility allows a single missile type to address a wide array of target sets. Strap on commercial GPS plus a domestic inertial unit. Leverage readily available, cost-effective commercial GPS technology for primary navigation, but crucially back it up with an indigenously developed, robust inertial navigation system (INS). This provides redundancy, resilience against jamming, and reduces reliance on potentially vulnerable foreign components. The multi-mode GNSS integration seen in FATAH-4, GPS GLONASS, Beidou further enhances this. Keep the unit cost under $1 million. This is perhaps the most challenging yet most critical piece of the puzzle. By focusing on efficient design, domestic production, and leveraging existing technologies where possible, a nation can keep the per-unit cost low. This affordability is what enables saturation attacks and allows for the procurement of sufficient numbers to constitute a credible deterrent. Focus on conventional deterrence. By developing these capabilities, medium powers can create a conventional deterrent that is robust enough to dissuade aggression without constantly teetering on the brink of nuclear escalation. It provides options for proportionate response. Pakistan has shown that this template works. By focusing on indigenous development, smart integration of commercial and military technologies, and a keen eye on cost-effectiveness, they've developed a weapon system that is both highly capable and affordable. This approach allows nations to deter potential adversaries, protect their interests, and maintain strategic autonomy without bankrupting their treasury or becoming overly dependent on external powers. It's a pragmatic pathway to enhanced security for nations navigating a complex geopolitical landscape. Section 15. Summary in one slidelet. Is distill everything we've covered about the FATAH-4 into a quick, punchy summary, the kind of slide you'd see in a high-level briefing. 750-kilometer reach, MESEP 330-kilo punch, long range, pinpoint accuracy and a potent conventional warhead. Flies at 50 MRSM, RCS under 0.05 mir. Terrain-hugging flight and stealth design make it incredibly hard to detect. Costs under $1 million, producible in batches. Affordable unit cost enables mass production and saturation tactics. Army Rocket Force owns it, keeping nukes out of the conventional fight. Dedicated conventional missile command ensures escalation control. Enough accuracy to knock out a bridge abutment. Enough numbers to saturate a battalion of S-400s. Precision for high-value targets. Volume to overwhelm advanced defenses. Conclusion. After all this, is the FATAH-4 truly unstoppable? In the real world, let's be honest, nothing is truly invincible. Every weapon system has its vulnerabilities. Every defense system its weaknesses. That's the enduring reality of military technology. But here's the critical point. The FATAH-4 missile stacks enough low observable technology, intelligent navigation, and sheer affordability to make the defender's life absolutely miserable. It's not about being invincible. It's about being incredibly difficult and costly to counter. This missile fundamentally shrinks India's comfortable reaction time against incoming threats. It forces them into a frantic, desperate scramble to intercept. It compels them to invest in costly upgrades, develop new countermeasures, and rethink their entire air defense strategy. For Pakistan, the FATAH-4 hands them a conventional lever, a powerful precision strike capability that has long been missing from its toolkit. It provides a credible conventional deterrent that can achieve significant strategic effects without immediately escalating to the terrifying nuclear threshold. Ultimately, peace in South Asia, as in any volatile region, rests on the delicate balance of diplomacy, mutual understanding, and a genuine commitment to de-escalation. But until that talking truly starts, until genuine peace takes root, the side with more cards, or in this case more highly capable and affordable missiles, inevitably gets to set the tempo, to influence the strategic calculus, and to shape the narrative. The FATAH-4 has just dealt Islamabad a fresh, potent hand in this high-stakes game. It's a new chapter in an old rivalry, and its implications will reverberate for years to come. Too like what you heard? Don't just sit there. Smash that subscribe button and share this video with that friend who still thinks cruise missiles are slow, outdated dinosaurs. They've clearly got some catching up to do. And seriously, comment below. If you were a military strategist, would you put your money on saturation with affordable, precise missiles, or on interception with advanced, layered defenses? Let's keep this debate rolling and uncover even more insights together.